The antimatter bomb is a world-ending weapon. It is so powerful. Most people don't even understand the scale of what it does. First off, if you're curious about what antimatter is, it is literally just the opposite of matter down to a subatomic level. So every atom has something called a proton, a neutron, an electron. In normal matter, electrons have a negative charge, protons have a positive charge, and neutrons have no charge. But with antimatter, electrons are positively charged, protons are negatively charged, and neutrons still have no charge. But what makes them the opposite, the anti-neutron, it has to do with quarks. But I'm not going to waste your time talking about quarks and anti-quarks because this isn't a scientific channel. And the thing is, antimatter was hypothesized to have existed by 1928, and it was actually discovered in 1932 by Carl Anderson in the United States. And in modern times, antimatter is generated almost every single day with the Hadron Collider and all of the other super atom smashers all around the world. Now, what makes antimatter so freaking destructive is that if it ever comes into contact with its opposite, like a proton meeting an antiproton, they completely annihilate each other. It is not an exaggeration. It is actually a fact. And in their annihilation, they lose all of their mass and they release a great deal of energy. And there's an exact amount too, mc squared. The mass of these two particles times the speed of light squared, which is a freaking huge number. To put it in better perspective, let's compare it to Hiroshima and Nagasaki. These bombs were powerful and they were measured in kilotons, or at least, their explosive force. So the bomb at Hiroshima was about 15 kilotons, meaning 15,000 tons of TNT. That's a great deal of destruction. But then in the 1950s, we developed the fusion bombs, or the hydrogen bombs. And this was measured in megatons, or millions of tons of TNT. So those things could take out a large city like New York, no problem. I looked up as many estimates as I could as to what is required for a 1 megaton blast in a typical hydrogen bomb. And at the very least, you need 6 kilograms of hydrogen isotopes. One is tritium, the other is deuterium. Now, I'm sure the real information is classified, but some estimates say that you need 100 kilograms or 1,000 kilograms to generate this kind of explosion. But to make a 1 megaton explosion with antimatter, you just need 23 grams, or about 1 ounce. In fact, 1 gram of antimatter is the equivalent of 3 Hiroshima atomic bombs. Just 1 gram. Fortunately, the antimatter bomb doesn't exist, and the cost of producing just 1 gram of that stuff is $62.5 trillion, so about 2 times the entire American GDP. Even though antimatter is being generated almost on a daily basis with all of the testing sites around the world, they are generating maybe nanograms of this stuff, and that is 1/billionth of a gram. And even if it is generated, it's not going to stay there for long. It's highly unstable because antimatter is eventually going to collide with some kind of matter and annihilate. But don't get me wrong, CERN and these other centers for particle acceleration are able to successfully trap antimatter and keep it, but nowhere near enough to come up with a gram or even a millionth of a gram. I mean, maybe, just maybe, DARPA has something, because antimatter pretty much is going to be the next state of unlimited energy. It'll be even better than fusion energy. And look, fusion energy is at least 20 years away. But something very cool is that antimatter is being researched to look up propulsion technologies to get spaceships to go not just to other planets, but to other stars. Something that is pretty cool is we are now talking about antimatter the way people did with nuclear energy in the 1930s and 1940s. And look how far we've come. I am the Geo Husar, and if this was your first intro to antimatter and its applications, let me know. Thanks for watching.